Well, welcome everyone. It's lovely to see you here at the Test of Time Awards session, and I'm going to turn it over to Manolis to do the introduction.
Hi everyone, great to see you all here. The speaker doesn't need introductions, Ryan Baker, but the paper and the award might need. For those of you who are not familiar, the Test of Time Award is given to a paper that was published 10 years ago and has been particularly influential to the field. There wasn't, and whoever is chairing this small committee that does the selection is doing the presentation. This was selected earlier. So I wasn't chairing them, but I'm just kind of doing the introductions now. And so the paper for this year is the State of Educational Data Mining in 2009. That was a review and feature revisions at the time, which personally I have found very useful for my students, and together with Cristobal's review has always formed part of my readings for the students. So I find it, I'm really looking forward to the talk. I understand that Ryan and Carlina have made a pre-recorded video of the presentation, and I hear they also have a guest speaker. So we'll start with that. Feel free to use the chat to write comments, questions as you are attending. Ryan is here with us, so he'll be able to answer any questions, and it will not be distracting since there's the video at the same time, and just writing will create kind of a feeling of a community rather than just a presentation, and then we can take it from there for questions and discussion in the end. So I guess, Anna, please start the video, and I'll see you in the end.
Hello, I'm Ryan Baker, and today, on behalf of both myself and Kalina Yacef, I'll be presenting the talk, The State of Educational Data Mining in 2009 and Today, Then, Now, and Forward. This is the Professor Ram Kumar Foundation Educational Data Mining Test of Time Award talk. Thank you for your support. In 2009, Kalina Yacef and I published an article, The State of Educational Data Mining in 2009, a Review and Future Visions. I think the title of this talk alone will tell you that we were trying to capture a specific moment in the development of our scientific community. Apparently, and honestly somewhat surprisingly, this paper has also apparently stood the test of time. And back in 2009, Kalina and I had a few thoughts about where the community was and where we thought it was going. And one of our contributions in this paper was to suggest a categorization of EDM methods. Now, it's worth noting that this wasn't the first categorization of EDM methods. That would be Romero and Ventura 2007. But perhaps, and I don't really want to make any claims about this, but perhaps we were the first to really ask which methods were specific to EDM. I've pasted up our 2009 schema here, and rather than read these to you, I'll just encourage you to pause the slide and read it yourself for a moment. Back in 2009, we discussed how common each of those methods were and what the current trends in the field were, such as, for example, the increasing public availability of large educational data sets. We also discussed some of the key applications of EDM, and I'll review these in a few minutes. So one thing that's worth asking is, what from that article is still relevant today in 2020? First, I'd like to say a few words on discovery with models. What's discovery with models? Some people think it's a little tricky, but in fact, I still maintain after all these years that discovery with models is so simple that a 6-year-old could explain it. And here yet again to do so is a 6-year-old, Maria Baker.
The big idea of discovery with models is you develop a model of some phenomenon using prediction, clustering, or knowledge engineering. Then you use that model as a component in another analysis.
Thank you, Maria. So, as Kalina and I pointed out, back in 2008-2009, discovery with models composed almost 20% of EDM papers. Now, a quick look through the papers at EDM from last year, 2019, shows that, again, almost 20% of papers involve discovery with models. almost identical to where it was a decade ago. The algorithms and the models that we're using have changed over the years. But as a community, we continue to use those models to better understand the phenomena that the models represent. Our community isn't just trying to build better predictions and adaptive systems, we continue to try to understand learning and learners as well. A second topic that's worth talking about is latent knowledge estimation. Now, in latent knowledge estimation, and I apologize for not having a 6-year-old to explain this one, but it's a little trickier. In latent knowledge estimation, a student's knowledge of specific skills and concepts is assessed by their patterns of correctness and other information. And latent knowledge estimation is discussed as an application in Baker and Yacef 2009. The term itself doesn't show up until a couple years later. But since we talked about it as a topic, I figured I could talk about it today. Over the years, latent knowledge estimation has become a really important problem in EDM. And in fact, at EDM 2019, last year, there were 28 articles involving latent knowledge estimation. Now, it's worth noting that the problem of latent knowledge estimation is sometimes confused with its most common evaluation metric, correctness on the next problem. It's not the same. An algorithm that perfectly predicts problem correctness within a learning system, but can't predict performance outside that system, has relatively limited utility. Latent knowledge estimation has become really prominent. It's now seen in both simple and sophisticated forms in dozens of adaptive learning systems, and it's used as a feature or component in many other algorithms, models, and types of analyses. One thing that's worth talking about in any discussion of how the field of EDM has developed in the last 11 years is deep learning. Has deep learning changed everything? Well, let's start by saying, has anyone working in EDM not heard of deep learning? I'd ask you to raise your hands, but that would be kind of silly given that you're watching a recorded video of me, probably all alone at home. So, deep learning has shown up in a lot of papers at EDM and related venues in the last few years, and it's led to better performance in problems ranging from detecting affect, to modeling the properties of educational videos, to deciding when to end an adaptive assessment, to mining textbooks for assessment items, to inducing pedagogical policies, and perhaps most notably, deep knowledge tracing. You know, that said, a lot of EDM papers still do use traditional algorithms. Deep learning's been useful for a lot of problems, but the difficulty of interpreting models makes it harder both to use them and to iterate them. And hyperparameter and structure selection turns out to be kind of just as much work as feature engineering. So deep learning is a good method to be sure, but it doesn't really magically change everything, in my opinion. As a related question, by the way, we can ask, has deep knowledge tracing changed everything? After an initial bubble of enthusiasm, after Peach's original paper in 2015, and, to be honest, a rather surprisingly quick bubble popping with an entire session at EDM devoted to criticizing that paper, there's been pretty thorough investigation into DKT's benefits, limitations, and how those limitations can be addressed. With work by Jung and his colleagues, which I really like, addressing interpretability, stability, and degeneracy issues in DKT, and some recent work by my graduate student Richard Scruggs, looking at how we can connect DKT estimates to the knowledge that students actually carry out of the learning system. And that work suggests that DKT is not just better at predicting performance within the learning system, but also better at predicting how students will do in external tests of their latent knowledge. And so I'm kind of convinced, I'm kind of a new believer now. DKT is pretty cool. So maybe more generally we can ask, have new methods changed everything? So I mean, there have been a lot of great new methods since 2009, both coming from the broader machine learning and statistics communities and from our own community. And some of these methods have been quite successful. To my eyes, though, the core problems that our community is working on aren't radically different than they were in 2009. Back in 2009, Kalina and I talked about some key applications of EDM: improving student models, predicting student failure or success, discovering or improving models of domain structure, discovering what pedagogical support works best in general and for different groups of learners and different situations, and refining or extending educational theories and our understanding of key phenomena. I mean, I don't know, maybe I'm just a dinosaur, but none of these seem radically outdated, although it doesn't seem to me that our field has made as much contribution back to theory as Kalina and I would have hoped back in 2009. So in terms of these practical applications, I think it'd be fair to say that they've been successes. For improving student models, well, affective computing in education and knowledge modeling, the models we have today are much better than in 2009. Predicting failure and success, well, K-12 dropout prediction is now deployed to millions of students a year, and the models are validated to work across groups of students. Discovering or improving models of domain structure, knowledge graphs underpin several modern adaptive learning systems, and it seems like they're faster to create than they used to be. And discovering what pedagogical support works best, what works for who, to use Beck's phrase, well, honestly, we're still struggling with this one as a field. We've got some good examples, but I wouldn't say that we're radically better than the work, say, that Cecily Heiner and Jack Mostow were doing even before the paper by Kalina and I. So this one's proven still to be a challenge, although there are some positive examples. I like Adam Sales's work. So what else is new and different in EDM? In the next few minutes, I'll discuss some of the other themes and trends in our field since 2009. One big development is the fragmentation of the field, and I'll be honest, I totally didn't see this one coming back in 2009. In 2009, EDM work appeared at EDM and maybe AI and Ed. And I personally thought it was going to expand to other conferences in education. But what I didn't expect was that the Conference on Learning Analytics and Knowledge and the Journal of Learning Analytics, ACM Learning at Scale, the International Conference on Quantitative Ethnography were all going to emerge. And you can now publish EDM work in all these places. In fact, and I hate to call somebody out because, Dirk, I'm a big fan of yours, but I just read a paper that called itself a systematic review of the use of learning analytics to improve learning and reduce dropout in higher education. And it included what the author saw as the 24 most prestigious or relevant journals and conferences in the field. And this review did not include in its inclusion criteria EDM or JEDM. There was one article that appeared in the citation list. And there's a lot of relevant research on this topic in EDM, JEDM. And I take this not, again, as a sign to just call out one group, as to say, wow, our field's gotten fragmented, that somebody could accidentally miss EDM in a review on EDM. I mean, it boggles my mind. And I'll admit, it troubles me, because if we don't read each other, how can we learn from each other? And if we don't learn from each other, how can we fix the big challenges of our field and make the big difference that we want to make in education? So, it's a call to everybody, please. If you're an EDM person watching this talk, read LAC, read ICQE, read AI and Ed, read ICLS, read ACM Learning at Scale, and if you're from one of those communities, read EDM. Let's keep reading each other. My gosh. Now, how the heck did this happen? How did this fragmentation happen? I believe there are deep and philosophical reasons for this fragmentation that have to do with how we think about data analytics and actually stem back to long-standing epistemological and ontological debates. And it's totally out of the scope of today's talk, but Dragan Gasevich, Shamia Karambaya, and I are working on a paper related to this. And email me if you want to be added to the eventual preprint list. So I think it's fair to say that the broader community of scholars who are interested in using data mining in education has grown a lot. And clearly the perceived value of this work is expanding, but are we making a difference? That's one of the questions I'd like us to be asking ourselves. What are some of the big challenges and problems for EDM? Because we're only going to succeed as a field. And maybe I mean EDM, maybe I mean EDM, learning analytics, learning at scale, maybe I mean education. We're only going to succeed as a field if we take on big challenges and we make progress on them. But that raises the question, what should those challenges be? I tried to offer my answer to this question last year in a talk at Learning Analytics and Knowledge and a paper in the Journal of Educational Data Mining. And I titled it the Baker Learning Analytics Prizes, and there were 6 prizes. The first one, transferring student models between learning systems. The second, looking at the long-term effectiveness of EDM-driven interventions. The third, model interpretability. The fourth, bringing knowledge tracing and student modeling beyond the screen. The fifth, general purpose detection. And the sixth, generalizability of models, which I referred to as the New York City and Marfa problem. To learn more about this, including a video of the original talk, the journal paper based on it, a detailed description of the competitions, and details on the $7, now $7, cash prize, go to this link. Now, algorithmic bias is a part of BLAP, the 6th competition, but I'd like to say a few more words on algorithmic bias. Algorithmic bias is a major theme that's become more important to the discourse around artificial intelligence, just in general, in recent years. And I can think of 2 ways in particular that it applies to EDM. First, do our models work less well for members of historically disadvantaged groups? In other words, do we have models out there that we're applying to some populations and they work well, and other populations and they're secretly not working well? The second is, do our uses of models produce worse outcomes for members of historically disadvantaged groups? So it might be that our models are equally accurate, but that the ways they're being applied in interventions turn out to be disadvantageous for people who have already been historically disadvantaged. There's evidence that this is a problem in EDM. First of all, EDM models and findings from historically overrepresented groups and countries can work poorly on other populations. And this is true both internationally in Ogun's work, in terms of gender in Gardner's work, and within a country in terms of English as a second language and urbanicity status in Karumbaya's work. And the group differences that matter aren't always obviously what we think. Okunpa's work showed that there wasn't actually much difference in one case, affect models, between urban and suburban populations, but there were big differences for rural populations. Now, despite the importance of these problems and the increasing evidence that they matter, a recent review by Paquette et al., appearing at this very conference, finds that only about 15% of EDM and JEDM papers use demographic data and analyses in any way whatsoever. So we've got a long way to go before we can really start to feel like as a field we're dealing with the problem of algorithmic bias. Now, in the original BLAP talk and paper, one of the things I called for was to say, if you don't like this set of problems, come up with your own ones. And I'm pleased to say that Radek Pelinek did. And he proposed a different set of things that the field should be focused on. And I think this is great because we're only going to address the most important problems if we actively debate amongst ourselves what the most important problems are. So Pelinek said, no, we don't want these competitions. That kind of focuses people overly much on small things. Instead, we want to focus research on bigger topics. 3 in particular. First of all, understanding and addressing the trade-offs in learning environments. Under-practice versus over-practice, learning versus engagement, and hint usefulness versus gaming the system. Second, we need to clarify methodological issues in our field so we can all go forward with the highest quality methods and best practices. And in particular, we need to better understand our metrics. And third, we need to increase the scalability of our system development so that we can deploy EDM systems at much greater scale and much more quickly than we've done so far. I mean, so these are fairly different in kind on the whole than the BLAP challenges, but they're clearly also worthwhile goals. We can't solve the big societal challenges unless we address the technical ones. So I thought this was a great complement to what I talked about in BLAP. My co-author, Kalina Yacef, also had some ideas around some challenges, which I hope she'll be writing up in a paper fairly soon, which include, first, adoption and trust. EDM can improve teaching and education, but teachers need to be able to trust the information that EDM models give them, or they won't use it. Second, the transferability of EDM methods across applications. A lot of papers describe EDM methods in a single dataset, but there hasn't been much research looking into how well methods work across datasets and contexts, or to codify guidelines for using a method on a new dataset or system. And third, the scalability of EDM methods. EDM datasets remain fairly small compared to the broader big data world. And tens of thousands of students may seem big to us, but it's not that big in terms of worldwide educational systems. And not many papers are looking at whether their methods will scale up to much larger data sets, which is going to be needed for the wider adoption of EDM methods, both in terms of accuracy and running time. Another important area which Kalina and I discussed as we were thinking about this talk was how educational data mining can advance data mining. EDM has interesting challenges. How do we better attract data mining and machine learning researchers to them? Researchers have joined EDM from the data mining machine learning world, but the ideas that those researchers have and that we have don't seem to flow back to data mining and machine learning as core problems in the way that's happened with, say, e-commerce or bioinformatics. And data competitions like the KDD Cup in 2010, kudos to those folks, and the Assessments Longitudinal Data Challenge that Neil and I put together, these can play a role, but they don't seem to be enough. And one of the problems with these competitions is that in order to create them, we often have to simplify our problems so that they neatly fit into challenges. And that limits the potential benefits to both fields because we don't capture the full richness of what we're really struggling with in EDM. Another critical question is the degree to which educational data mining has advanced and influenced educational theory. EDM has made an impact on educational practice, as I talked about a little while ago, but has it really made the contribution to theory that we hoped it would? A lot of the work in EDM and our related sister communities is opportunity driven. There's lots of data available, there's new information to extract, new questions we can ask about, rather than theory driven. And that's not inherently wrong. I mean, there's a lot of interesting phenomena that we're starting to see that don't have a base in theory. And where it's relevant, there is considerable discussion of theory in our papers in the EDM community and our related sister communities. So we're using theory as a community, but could we play a bigger role in contributing back to it? For one thing, if we were driving our research more in terms of theory, then we could be more clearly designing our research in ways that would contribute back to that theory. And again, there's a place for pre-paradigmatic research. There's a place for studying phenomena that we don't have theory about. But it would be nice if we could be playing a bigger role in contributing back to theory. And to be honest, theory in education these days in 2020 is more verbal and less computational, less precise than it was when EDM started as a field. And that's kind of a shame that we haven't played a bigger role in pushing that in the other direction. So, to offer a few concluding thoughts, EDM has now been around as a community for about 15 years. First EDM workshop, 2005. And we're now 11 years past Baker and Yacef 2009. And in that time, the use of EDM and the scope of EDM reach has just exploded in magnitude. And as our field grows, it becomes clearer and clearer that we have big challenges that we need to solve together, making our technology scale and ensuring it's valid for all learners, contributing more to theory, and making a bigger and better difference in practice. We're going to need to keep improving our methods and asking ourselves difficult questions in order to solve these challenges. That said, we have made a lot of progress in the last 11 or 15 years, and I think a lot of that has to do with you. EDM has succeeded in impacting education because of the contributions that you've made, the EDM community, and our friends in related scientific communities. EDM is going to continue to impact education if, and probably only if, we take on important problems in the world and take on the challenge of continually making our field and ourselves better. And I'd like to thank you for coming to this talk and sharing a few minutes of your life with me to hear my thoughts on this. I'd like to thank you for what you do as researchers and practitioners, and please let me and Kalina know what we can do to help you bring the field forward. Let me be frank in these waning seconds of the Test of Time talk. Ultimately, while I'm really honored by the award, it doesn't really matter if our paper stands the test of time. With apologies, it doesn't even really matter if our community stands the test of time. It matters if our contributions to the science and practice of education stand the test of time. Our community is growing up, and children are growing up using the technologies that we help develop throughout their childhoods and into their lives in the workforce. We have a great opportunity to make the world better. Thank you for being part of that.
Thank you, Ryan. What a great video. Thanks you, and congratulations again. And I take your last point about what really matters in this area, and I think that can be a great opening for a good discussion. I'll welcome questions then. Now, I think we're quite a big group, but all well informed enough. If you wanna, people can sort of express their interest for a question. We can let people in, or feel free to write it and can take it from there. I guess some people are writing. Ryan, I don't know if in the meantime you wanna comment kind of verbally on some of the comments that were earlier, particularly. Some discussions seem to be going on around the DKT model.
Yeah, actually, I got really engrossed by the chat and stopped listening to myself. Fortunately, I already knew what I was saying. I think there's some great discussions here of issues of the possible contribution of model parameters yeah, to theoretical understanding. I actually really have struggled with this because I think that we are producing a lot of things as a field that theoreticians should be including in their models. I think we are producing a lot of important findings, but I think that the broader world of education researchers is sometimes still uninterested in them. And I think that part of that is sometimes that the findings we have don't map to the theories they already have. And I think of this, for example, in the moment-by-moment learning graphs work I did years ago with some colleagues, where we tracked, the patterns of learning and whether or not you like the exact method we used for it. We discovered some really curious things about like plateaus in learning, and the broader world of education, it didn't map to any theory. And the broader world of education largely completely didn't pay attention. And I think that in some ways in EDM, we are thinking about problems that are very important to adaptive learning, very important to predictive analytics. We're not as connected to the theoretical models. We've actually been working in our group to try to like really hone in on components of Winnie's theoretical model and use various types of analysis to look at it. That's like not published yet work, but I do think that that's part of the challenge, is that we are talking about a lot of phenomena that a lot of theories haven't even thought of. There's also been a great discussion of I'm just seeing the chat window explode to my right. Of estimation. Yeah, I can't actually present this because there's such a great discussion between Phil and Ken going on in the window about prediction versus estimation versus understanding parameters. And I do think that there's contributions to being able to understand parameters, but applications where we just want to predict either within system performance or the learning that's going on. So I don't know how to answer a question on that because it's just an exploding discussion, which is great to see.
I guess, Ryan, one thing you might address is...
Ken can come in. Yes.
Yeah.
Okay.
Yeah. Is I think we're starting to better understand how various elements of data produce bias. Missingness is a huge one. So sparse data, where, just to give one example, and I think it is challenging for DKT amongst other methods, is that in our data sets, items or questions or problems often occur in, do not appear at random. And an item that might be later in the curriculum sequence may end up in some models getting looking like it's easier. So the item parameter sucks up some of what the learning parameter might otherwise get credit for. And if the item were, randomly distributed, you'd get better estimates of learning and item difficulty together. That's just one example, but I think, should we be working harder on figuring out ways to address missing not at random?
I mean, I think that's a great point in that, and I agree that's a really big challenge to interpreting parameters in a lot of the existing approaches. The fact that items are not randomly distributed, they're in a non-random order. I mean, I honestly wouldn't, and I don't want to get too much in the weeds of that one specific paper, but when Richard and I looked at DKT and its ability to predict external performance compared to all these other algorithms that explicitly try to consider a latent, we were blown away that DKT did better in that case. And we seem to be replicating in another data set. So there's some extent to which that algorithm is being successful at abstracting some element of understanding that's more than just contingent performance on items, which is a lot of what I thought it was capturing. Like when you add in lots of item parameters, you start to really get better prediction of student performance by dint of having better prediction of the items. And that, by the way, connects to Sherry's question a little bit, which is, don't understanding parameters depend on having a canonical solution of the optimization, not having a local optima. I mean, I totally agree with that. Like if you have a bad parameter set, if you don't fit very well, you can often misinterpret in various ways. There's a lot of interesting challenges, and at the same time, these challenges aren't new to EDM, right? People have been misinterpreting 3-parameter multiple regression models for decades. And it's sometimes amazing to me how people will throw two things that are highly correlated, have high collinearity into a model together, and then they'll interpret their parameter values, even though you'll find that something flipped its sign because of the linearity issue. And Jack says, can you define theory in education better than a set of strongly held beliefs not necessarily supported by data? I would like to think that there is better theory than that. And I would start with, I know that, I mean, Lakatosh argues that theory is a model that predicts the existing data, but also makes generative predictions that are useful. And I don't know how much of that we have in education. We have, for example, Bloom's model of school learning, and we have social cognitive career theory. We also have a lot of frameworks, and CLE, of course, Ken's here, I can't not mention CLE, but I would also kind of list Winnie's work as a framework that you can hang. I don't know that Winnie's work makes clear predictions, but it is a framework that you can hang clear predictions on, much like the goal of CLE. So I would say that if you take those kind of good frameworks like social cognitive career theory, Winnie's Cope's model, or CLE, you can start to hang theory on them, and those models present clear places we should be looking at. Like in social cognitive career theory, we can clearly look at it and say, okay, engagement should be in this model, but where should it be, and what are the processes through which engagement, you know, impacts the developing relationship between students' self-beliefs about their career potential being affected by their learning experiences, successful and unsuccessful. Yeah, ICAP too, thank you, Ken. I omitted ICAP, but that's another, and actually ICAP, though it's narrower than some of the other ones, does actually make some pretty concrete predictions that one can test.
Jack, you wanted to come in. You put your video on. We can't hear you.
I just thought it was polite to show my face now that it doesn't include my breakfast.
Okay. All right. I have a kind of relevant point sort of question, and maybe we can, while others are writing as well. I think you didn't elaborate a lot. You touched a little bit on the video. You also mentioned it just now. If you have any thoughts on how this disconnect between theories and EDM feeding back to education, but also like in real practice, sort of like how these methods can be applied, and what would be the process for achieving that? Like, I was thinking if you have any ideas on these like practical ways that EDM can sort of specifically start feeding back to education for folks to adopt this kind of thing.
Well, I mean, I think you started by asking about theory, Manolis, but I also heard practice in there. I think we are contributing to practice pretty concretely. I think that a lot of adaptive learning systems are getting widely used, and they're using our ideas and technologies. Sometimes kind of older versions of them, but still, I think that K-12 predictive analytics has become a huge thing in the United States in the last 5 years, and higher ed predictive analytics a huge thing in the United States, the UK, and other countries. In the US, Bright Bytes and Clever together have probably around 5 million K-12 students being predicted. So I think we're actually succeeding there, and I think it's by actively connecting to those communities. The industrial track is a sign of that, but just the more EDM people work with those people, I think it helps. As far as theory, I think it's tricky because I actually think that the kind of ways that a lot of Jack kind of said in his post about, big ideas not supported by data. And I do feel like a lot of the thinking around educational theoreticians can be that way. I actually think Vygotsky, who's probably still the most cited educational theorist of all time, actually is not woolly. Vygotsky's thinking about very concrete problems. And 2 days ago, Wilma had a talk with me on our continued work to study the ZPD and to actually measure the ZPD. I think that the more that we connect those ideas, the more those people will be able to hear us. That's not to say, however, I also think that one of the things that EDM is doing is playing that pre-paradigmatic phenomenon discovery role that Thomas Kuhn talks about in the Structure of Scientific Revolutions. In a lot of ways, educational theory has been limited to the things that could be easily seen by somebody sitting there and talking to a kid like Piaget, or bringing people in the lab like Vygotsky, or going out and teaching in real-world settings like Freire. And I think that we're actually seeing a lot of phenomena. And one of our challenges is to make the bridge where we talk on people's languages something where we can also start to import the kind of phenomena that we see in EDM that don't have educational theory around them. How can we better connect to more communities so that they know about EDM? Tiffany asks. I mean, I would say that, I mean, I don't know, you know, over the years we've had, I don't entirely know that we've done a good job of advertising the outside world. LAC has been much more successful at advertising to the outside world. And I think there's two reasons for that, at least. One is that they're just much better at that process. I mean, they have all kinds of webinars and seminars and resources, and they sustain that. And they just have a lot of skill at that, which I attribute to the kind of style and skill of some of the early leaders of them, which is, you know, as the first president of EDM, I didn't have that skill and style. The other thing I think is that they're just a little bit closer to the mainstream of educational thought in a lot of ways than we are, which makes it easier for people to come in and also easier for people to learn from them. The right side is just exploding, but I agree with Agat's point about involving more of the teachers in the loop. I think that there's several reasons why that's utterly essential. Not least of which is that if we don't develop technologies that teachers find agreeable and valuable and that they can trust, they're not going to use them. And the EF plus math group out of Chan Zuckerberg and Gates put out a white paper a couple weeks ago, I guess, sorry, on why working with teachers who work with students with large populations of historically disadvantaged students is really important for developing technologies. And I think that's a theme that we've seen in EDM as well over the years.
Kind of on this trust issue, Neil was asking as well, like, what can we do about this? More, again, kind of practically, I guess.
So, I mean, I think it's hard, right? People tend to be skeptical of technologies that aren't perfect and trusting of humans that are imperfect. And oftentimes people have this belief that medical diagnostics are magically perfect and that educational diagnostics are inherently impossible. And the human body is a complex system as well. I saw a couple frowns, and I guess the thing I'd say is that, like, people tend to, not relevant to our current pandemic, but in a previous worried about pandemic, Ebola, the test that they were using had a 16% false negative rate, and yet they were making life and death decisions on the basis of something with a 16% false negative rate. People tend to assume those models are perfect, and they tend to assume that education models aren't, but in fact, like, a lot of models published in EDM have better numbers than models used to decide which HIV inhibitor to give people. So we have a lot of work to do to kind of communicate to people that these things can be valid and why and how they would be valid. I do think that including teachers in the loop of developing will help us speak the language of teachers and maybe catch some mistakes we're making. I also think that it's just, in some ways, going to be a matter of time until people are more comfortable with these things, and that situations like, say, online learning, if we could incorporate some of these things a little more and get them to work right, it would go a long way to people having comfort.
Thanks. I think that's kind of a good positive point to end, but maybe we can just take this last question by Sed, if you're reading it, or I can read it to you.
Sure. So
we have another minute or so. Kind of. Go ahead.
So first, let me just say that anyone who
lost him.
Conversation is welcome to email me or welcome to, I mean, there's various forum where we can continue this conversation. I actually think that the split between educational measurement and EDM has been an ongoing problem. There are a lot of people in educational measurement who don't feel that way, who are very open and receptive to our kind of work. And those people, some of them come here or have come here in the past. And I think EDM has actually done a better job of reaching out to educational measurement than most of the other communities in our space. I think that that some of those folks, and I'll go back to Kuhn here, you know, some of those folks are never going to accept EDM because it's just a different way of looking at the world. And some of those folks are open and receptive. A quick plug, Brian Keller, who's a statistician at Columbia, and I actually have a special issue of Behavior Metrica soliciting papers on integrating EDM and educational measurement. So I would encourage you, if inclined, to apply it, to submit papers there, and if not inclined to submit, to read it. But I think that more conversations can get the educational measurement folks who are receptive to EDM to understand what we're doing and to contribute back their incredibly valuable ideas. So thank you everyone for coming. I hope this conversation will continue. And I guess I'll lower the floor so we can all go to our next session.
Yes, thank you, Ryan. Congratulations again, and thanks for everything for the community. And we'll leave you all. I think there's a coffee break. Anna, you want to take it from here?
Sure. Yeah.
Thanks,
There's
Ryan. That was great.
Yeah. Thank you. Yep. So then there's a coffee break now. I will probably just leave this session open for a few minutes, but you're also welcome to the coffee break session, and then the next paper session starts at 15 after. So thank you, Ryan. That was a great talk.
I'll stick around then for a couple minutes into the coffee break as well.
Did you say you were sticking around here or going to the coffee break?
Oh, I guess I'll stick in this room for a couple minutes and then head over.
Like talk to the professor after class kind of thing, or after the talk. Yeah.
Sure. Yeah.
I actually learned that in the spring that I needed to stick around after my Zoom talks to allow for that. Yeah, one of the things students value about face-to-face, which we can replicate if we're careful online.
I agree.
That was a great talk and fostered super conversation. Thanks for getting up so early.
Oh, it's not so early. I actually, with the 1-year-old, I actually get up at 4 a.m. or 5 a.m. many mornings.
Yeah, I imagine. Yeah. I'm going to go to the coffee break, I guess.
I think, hello, can you hear me?
Hi, Kalina. Great to hear you.
At some point, I tried to answer one of the questions, but you kept answering them so well. Anyway, you did a great job. Thank you.
You're
so
very
much,
kind.
Yeah.
Well,
and I love the intervention of your daughter.
That was great. Hi, Kalina.
Hello, Ken.
And
nice to hear you.
Hi, Neil.
Hey, Kalina. I was trying to get Ryan to actually speculate on the issues of trust, and there's probably more we could do there that he brought up that from you.
Yeah, the issue of trust is
with teachers.
Sorry, of teachers.
Yeah,
yes.
With teachers.
Of teachers adopting the I mean that's what we found in a lot of our work. It's that we find interest. Well, things that we find very interesting, but then teachers don't understand how the data is, how the information is extracted, and how it relates to what they've learned, how they've been trained. And I think that the issue of linking back to theory is important there, because if we make more of an effort as a community to link to the theory, and it's not just using theory, but it's actually also, for example, connecting empirical findings and linking them back to theory, then bridging that link with between data and theory will help engaging more teachers and education specialists into the field. And I think that's how we can grow and raise and increase adoption of EDM methods. But it's a very complex one to address.
Agreed.
Totally agree. And by the way, Ali, I'm sorry, I don't know how to pronounce your name, says, do we need more transparent approaches to gain trust of teachers and students rather than outputs of AI black boxes? I couldn't agree more. And I think that we are starting to see more work on explainable start to move its way into EDM. I actually really think that unless we can ask a model, why did you make that conclusion? People aren't going to entirely trust it in our community. I actually think that like K-12 predictive analytics people are starting to really do some nice stuff like with that. Like Bright Bites, for example, will make a prediction about whether a student's at risk, but then the teacher and administrator can drill down and it'll give 22 indicators that it's using, and it'll say which of the indicators it is making the prediction based on. And so it'll say, for example, this student is more likely to drop out of high school because they've had 12 disciplinary incidents. So I think it's a nice step in this direction.
Hey, thanks for answering my question about the measurement scientists.
You're very welcome.
Yeah, it's an interesting conversation. I've come from that kind of psychometrics background, and there's such a deep kind of strict theory approach that they take there. If there could be some middle ground between the two approaches, I think it would be so valuable.
I think there actually is a lot of work that hits a middle ground. I think it's just not really dominant in either community. I think about the work that Adam Sales has brought here. I think about the work that Junker and various students did a few years ago. I think about the work that Tracy Sweet or Andre Rupp have done. I think that like Yoav Bergner. So I think there are I think of the work that Val Shute and Russell Allman have done. So I think there's a lot of it, but the trick is that like, I think that work doesn't.
And Dr. Valdavia, she just presented on some really good middle ground kind of work.
Alina, yeah, I love Alina's work. There's just so many names you could think of. The trick is it doesn't really crack the nut of either side, right? The who are hostile to the sheer idea of EDM don't get persuaded by that work. And the EDM people who are just doing their EDM thing don't tend to adopt that. And it's just tricky to kind of be at the intersection of this.
This parameter estimation area would be one place where there could be some really productive dialogue, I think, because I do think that psychometricians focus more on the accuracy of the parameter estimations as they map to theoretical or practical constructs. Like the output of the model is fundamentally the parameter estimations, not the prediction. I think more so in psychometrics than in a lot of EDM. And of course, a predictive model that works well as a recommender is super. So I'm not saying no to black box, but I think in terms of this linkage. that would be an interesting place to, like, we don't do much reliability analysis in EDM, for example, but psychometricians do that a lot.
Yeah, it's funny, we do a lot more generalizability analysis and a lot less reliability analysis. And I think that's partly because of the goals we have and partly just a style thing, but it's fascinating to see.
Yep.
And on physiological measurements, yes, there's a lot of work like that. Multimodal learning analytics, quote unquote, has like a very prominent body of work, both theoretical and practical. Sana Yarvala's work, Sidney DeMello's work, Xavier Ochoa's work. There's just a lot of it. I think we can't put galvanic skin response bracelets on every student in America. In other countries, it's more feasible. I think that the applications of physiological and physical measurements are going to vary by age group and by country. And I expect we'll see a lot more of it in some countries and with older populations than we will in other places. All right, well, we seem to have quieted down. Should we all migrate? It was great to see all of you. Thank you for staying after the talk. Great to see your
Thanks, Ryan.
card, Ken.
Thanks, Ryan.
Thanks, Anna.